As Jinhua said, we have a sort of a two-tiered presentation here for lunch. Hopefully won't give you indigestion while you're eating. I'm going to start off looking at the past and looking at history. And then Julie will take it a step further and look into the future. But we wanted to start here really with looking at our past. There's a lot we can learn from it and also inform us on where we go for the future. And to do that, I'm going to start, and this, for some of you in the bleacher seats in the very, very back, you may not be able to make all this out, but there are many things we know about the climate before we had instruments. And I wanted to note a couple of these. One of the most interesting ones, I'll get my own glasses on here as well, dates back to several hundred million years ago. The Devonian and Carboniferous periods, 420 to 300 million years before present. Michigan and much of the Great Lakes region was a very, very tropical and moist climate at that point in time. And this is a little hard to see here. I put this on here for those of you who are from Michigan. You can't probably see it. It's a Petoskey. The state stone of Michigan, something you probably learned way, way back, is our state stone, a little image of it. It's fossilized coral. And of course it dates back to the same time frame, basically a part of this very, very warm and humid past. More recently, during the Pleistocene, we had several epochs of glaciation, and the last one, the Wisconsin epoch, the last glacial period ended about 12,000 years before present, and where we're sitting now was covered, at least prior to that, by a couple thousand feet of ice. So we've gone from tropical to glacial. In the more recent past year, during the Holocene era, during the last 10 to 12,000 odd years or so, there also have been some changes. After or following the last glaciation, Michigan actually warmed up relatively rapidly. It also became drier, and much of these findings are the basis or the result of pollen, sediment cores, other paleoclimatological research, but the Great Lakes themselves became terminal into the somewhat similar basins that they are right now, about 8,000 years before present, and we had a change in vegetation from boreal following the glaciation to a xeric species, or dry-loving or dry-resistant type of vegetation. And beginning about 5,000 years before present, the climate once again cooled and became wetter, and vegetation changed along with that. And then up in the last 1,000 years or so here, during the late Holocene, the region experienced a period of relatively mild temperatures or mild climate. This coincided with the Vikings' exploration of much of the North Atlantic. That was in turn followed by a cool down, once again, that started around 1400 AD and ended at the end of the 19th century. That's the so-called Little Ice Age. So I guess the operative theme here, there are many, many changes in our climate in past history. And I would make, basically in terms of thinking where Julie's going to go, one of the things to note, though, about these changes is they occurred over relatively long periods of time, thousands, sometimes millions of years. And that needs to be, I think, distinct from what we'll probably hear here in a couple minutes. There we go. Using instruments, which approximately 150 years or so of weather records, or at least reliable weather records around the planet. This is a series from Phil Jones at the University of East Anglia. Here, probably the best, I think, series of global average temperatures. And this goes back to the middle of the 19th century, once again, 1850 up through 2008. And essentially what you see here are deviations relative to a 30-year mean. So these blue departures here are periods in time where that year was cooler relative to the 1961 to 1990 30-year period. Red areas here more recently are years in which the deviation, the mean temperature, was above that 30-year average. And the thick black line here, and you're going to see several of these in upcoming graphs, this is a moving average, and it's plotted here. It weights over 9 years, and it basically filters out some of the year-to-year fluctuations. It helps separate some of the longer-term trends. And what this is an important record, important series. It's the best, basically the best records we have climatologically around the world. And it suggests strongly that the Earth on average has warmed about 0.75 degrees Celsius, or about 1.25 degrees Fahrenheit on average since about 1910 up through the present time. So that's the global temperature. What about here in Michigan? Much of what you're going to see now, we're going to move to Michigan. We don't have records quite as long as those that you've just seen. The first records in Michigan date back to about 1820. They were isolated Army records. They're fun for historical reasons, but we really don't have enough records in Michigan to really start to make a meaningful observations about trends until the latter part of the 19th century. This series here and the one that you're going to see after, well, a couple you're going to see after it, start in 1895, which is when we feel we have enough stations across the state, believable stations, to put together a record. And this is the average temperature, annual temperature, with all of the stations that were available at a given time. And what you see here, there are some similarities, a basically sideways temperature pattern from the turn of last century up through about 1960 or so. That was followed by a slow decline or slight decline up until about 1980, which was in turn followed by a more rapid upturn of, well, about 2 degrees Fahrenheit here that's occurred since 1980. And I want to, so overall, if we look at our temperatures here, an increase of about 1 degree Fahrenheit during this entire time frame. But a lot of it, interestingly, is concentrated here during the last 30-odd years, and I want to look at that in more detail. It turns out that that increase that you just saw of 2 degrees since 1980 is strongly concentrated by season and really during the time of the day. These are mean winter temperatures from a site up in the western Upper Peninsula in Ironwood that are representative for the state. And you see a little bit more variability here because we don't have as long a season. But these are temperatures taken during December, January, and February, and they are, excuse me, they are mean winter temperatures. We can also look at minimum temperatures, but much of this increase here is centered around this increase in temperature that started around 1980 and continues up to the present. We had a couple of cooler winters, 07, 08, 08, 09. This year was actually milder than normal once again this past winter. So much of the increase that you saw on the last graph is concentrated during the winter season and during night, minimum temperatures. Much less change in other seasons of the year. What about cold waves? And this is defined as 3 consecutive days at a well below normal. And the frequency of cold waves, this goes back also to 1895. Looking at the moving average here, you can see that back the early part of last century, there was a relatively high number of cold waves that occurred then. Then there was a relative drop-off during the 30s, 40s, and 50s, an increase up to a maximum that occurred in the 70s. And those of you who are old enough, like myself, remember some of the major winters back in the late 70s. There's no surprise that a high frequency of cold waves then, but it has since dropped off. So we have had a relative drop-off in the frequency of cold, at least extreme cold events during the wintertime. What about ice? And we've heard this mentioned several times. I think Bruce McCarl just mentioned it here. There are some significant changes to talk about with milder winter temperatures. This is a record of temperature, of ice cover on the western arm of Grand Traverse Bay, which is what you see looking due north into the western arm of the lake in downtown Traverse City. And this is the number of years out of 10 in which that body of water froze over during the wintertime. And it goes back, the nice thing is it's an earlier record, it goes back to all the way back to 1851 and continues actually up to the present. And what you can see here is a relative sideways pattern. 80 or 90% of the winters, that part of Lake Michigan froze over, and then there's a relatively rapid drop-off during the last few decades. Again, another symptom of these milder winter temperatures. Here's a more comprehensive view of the same thing, but less time. This is taken from some work at the Great Lakes Environmental Research Lab down in Ann Arbor, and actually looks at satellite, where they have spatially integrated ice cover over the Great Lakes, and this is the amount of aerial coverage of ice, which has been way up. This is all the way up as high as 100, I believe that's 100%, it may be a misplot, but there's a relatively rapid drop-off again in the early 80s that continues up through the present. And so there's just, the overall bottom line here is there's less ice for less time on the Great Lakes than used to be the case. Went a little bit too far. What about seasonalities? Well, there are some changes in our season. If we have less ice in the Great Lakes, we have milder winter temperatures. One thing that we also can see is springtime, the annual warm-up is occurring a little bit earlier than it used to. This is a graph of the entire region. This is a 5-state region we're looking at now, and it's a little hard to see here. The green line is the day in the last freezing temperatures of the spring. The blue is the first freezing temperatures of the fall, and then the red, which is probably the most important one here, this is the relative length of the frost-free days during the growing season. So that's the amount of time between the last freeze of the spring and the first of the fall. And what you can see here over time, once again, a change around 1980 or so, that there has been especially a decrease. Spring is coming earlier. There's also a little bit of a change in the fall as well here. That first freeze of the fall is coming a couple days later than it used to. And the net result here is an increase in frost-free growing season, or frost-free period, on the order of 7 to 10 days during the course of the year. And so, but much of this, I think, looking at the data we use, much of this is coming on the front end. And this year, of course, if we look outside at our redbuds and other beautiful vegetation here, it's currently about 3 full calendar weeks ahead of normal. So this year continues that trend. This follows up on the same theme. I think Dr. McCarl also mentioned the project with cherries, and this is from our Pilius project. Julie will talk a little bit about that. But this is the day of the year, that's on the y-axis here, in which we see stage 2, or this side green stage of cherries, and the phenology is dependent upon temperature. So the warmer the spring is, the faster the development occurs. And what you can see in this graph, this one ends in 2004, but you can see that that's come earlier and earlier with time. And again, in western lower Michigan, we see changes on the order of 7 to 10 days, earlier now than used to be the case just 30 years ago. So phenology is more rapid in the spring. I didn't say anything about heat waves. That's also another very, very important piece. Variability is important. If we look at the frequency of heat waves across the region, the 1930s stand out as being the benchmark, and you'll see then in the next image as well in terms of drought as well. So this is definitely related with dryness, but there hasn't been much of a real change in terms of the frequency of heat waves during the summer. In some parts of the Midwest, it goes even a step further. Temperatures now have even cooled a little bit versus what they were 2 or 3 decades ago. So not much change in terms of extreme heat. What about precipitation? Well, it's become wetter. I mentioned the 1930s. This is 1895 to 2008 timeframe again. Here are the 30s, and again, the driest decade that we have on the historical record, and you can see an increase on the order of 10 to 15% in mean annual precipitation that's occurred since then. So overall, Michigan and the Great Lakes region is warmer and wetter than it has been in recent decades. There are 2 ways you can get more precipitation annually. One is to have more wet days. The other is to have more precipitation per event. And it turns out, in our case in Michigan, it's a little bit of both. This is the fraction of days with measurable precipitation. This is a little shorter, goes back to 1930 up through 2008. But the number of wet days has increased significantly in Michigan and across our region. This is from Caro up in the thumb, but it's representative of the state as a whole. And you can see here an increase. The blue line is basically the number of wet days. The green line is the number of wet days which follow wet days. So both of those have increased significantly on the order 20–25%. That's fairly big climatologically. So some of that increase is due to more wet days. Some is also due as well to more extreme events. And we do have evidence that the number of extreme events, it's not a large change, but there is some change in heavy rain events during the last couple of decades. So both of those have contributed, and I don't have a graph to show this, but with more wet days, it should follow. It's cloudier. It's become cloudier than it used to be in the past. And as somebody who didn't grow up here, that comes as hard to believe sometimes during the fall, but it's true. We have the data to back that one up. What about snowfall? I'll finish up on that. Some interesting trends in snowfall. First, a series from Bay City up near Saginaw in the Saginaw Valley. If we look again at the 9-year moving average here, not much of a change over this period of record, 1897 through 2008. In some parts of southern lower Michigan, the snowfall, seasonal snowfall has actually dropped off a little bit with time. More interestingly, though, there are places in Michigan, this is Chatham, up in the central upper peninsula, where snowfall has increased significantly up into the last couple of decades. There's a little bit of a drop-off here at the end of this record, but we looked at, when we first plotted some of these, I thought that the person who did the plots in our office had made a mistake and went back and looked, and what we realized, we were seeing something very, very distinct. It's tied back to those temperatures I talked about before, because what you see here are changes in synoptic versus lake effect precipitation. And much of this increase that you're seeing here is an increase in lake effect snowfall during the season. And that accounts for, this has also been observed in many parts of the lower lakes as well, western New York, northwest Pennsylvania, northern Ohio as well, but a large increase in snowfall that appears to not be synoptic but more associated with lake effect snowfall. Even though the snowfall itself has, in some cases, become higher or increased, this is also at Chatham. This is the number of days with snow cover greater than 1 inch on the ground. And interestingly enough, look at the departure, the decrease here during, guess when, 1980 up to the present. So even though we've had more snowfall, the number of days with snow cover on the ground has decreased, which is also, once again, tied back to those milder wintertime temperatures. So all of these things are linked. I think there's a strong dynamic link between all of these different, even though they seem different. And I'm going to summarize, so Julie has a chance to talk about the future here. But without question, change is part of climate. We think, humans like to think of climate as something which is static. And over human lifetime, it is relatively static. But unquestionably, climate is dynamic. It's the way it works. And it has changed dramatically over our region. There are many, many pieces of evidence for that. In our instrumental record during the last 110, 120 odd years, Michigan has become warmer and wetter. Much of the warmer temperatures, though, are concentrated during the winter season, and especially at night. Precip has gone up. Now, there is some leveling off. I didn't talk about that, but there has been a little bit of a leveling off of precip. It reached a peak in the 1990s, but we're still right there now where we were back in the 90s. Snowfall depends on where you are. Lake effect areas have even seen some increases. Other areas have leveled off or maybe a little bit of a decrease. And definitely spring is coming as this season. This is, by the way, in western Michigan anyway, this is the earliest start of phenologically in 20 years in Michigan. So that trend of earlier spring warm-up is definitely continuing up to the present. And I think with that, I'm going to hand off for time's sake and have Julie come and look at the future. Thank you.